Hey guys, what's up? In today's project, I want to extract gold from BGA IC chips and estimate how much gold is possible to extract from about 270 grams of BGA IC chips that I have collected from mobile board circuits. And I'm out here to burn the ICs out to the ashes to make it easier to grind for further processing in my lab. This is the BGA IC chips, 270 grams of BGAs, and I'm gonna burn these out now. Now let's get our hand into the plan. Okay, these are our ICs that I wanna burn with this torch. Let's get started. We need the IC chips to become white in the color, not the black. We need the real ash. And now we have more ICs burned here, and I want to try to make all of the ICs to the white ash to make it easier to grind without any problem while grinding process. Okay, I have burned these ICs to the point that no more flame comes out of the ICs while burning by the torch, and getting the whitish gray color as much as possible. And I think this is the point that it's ready for grinding.
I separated all fine particles using a sieve, and I saved the big particles in another dish to check later if there is gold between them. So I add nitric acid to big particles to dissolve base metals as much as possible to let me decide better what I'm facing with. And I put it aside for later. To start processing fine powder, I turned the gold concentrator machine on that I made in previous video. I added some drops of rinse-it liquid from dishwashing machine to prevent floating particles on the top by breaking water surface tension. I started adding powder slowly to the machine while water stream adjusted to be low. But we have a problem here. Some powders still remain on the top of water and go to the drain box. So I decided to wet powder to make it heavier to sink in the water. When we were done with addition of powder to the machine, it's time to let it work for several minutes or maybe 1 hour to wash the powders properly. After that, to get much cleaner solution, we need to drain some used water and add fresh water on the top. I do draining and adding fresh water, or on other words washing, while increasing the machine speed to support enough water for draining.
And this is the result after several minutes of washing and wash the fine particles to the drain and adding fresh water, and this is what remained from that fine powder.
By washing these fine particles, we will not face with suspension, and this makes filtration process easier.
Now I turn off the machine and let it settle down, and letting the water comes down under this cone.
I started separating magnetic particles in this tub because here we have more space than a beaker to separate them. This is the magnetic particles and no gold is stuck between them. And this is what has been remain after washing out for several minutes, and all is coarse particles from the washing process, and this is ready to dissolve base metals into the acid. So I start transferring powder to a beaker for chemical processing. This is still black, and there is some fine powder that isn't finer than the initial powder that we washed out, and by passing time it starts to sediment at the bottom of the beaker. This is the coarse particles that I have separated in sieving process, and I treat it with nitric acid to dissolve base metals, and now gold is obvious. I transfer all nitric acid wash to separate dish to process later for silver if there is any. And gold is more obvious from this point. So I add this to the main batch to be processed with them. Before dissolving gold in aqua regia, we need to dissolve base metals first. So I add some nitric acid to the main batch. To prevent foaming, it is necessary to add nitric acid slowly. The ice is powder supposed to left in nitric acid for several hours, but it's been about 2 days that they are left in nitric acid. So there is a possibility that some base metals might precipitate out due to electrochemical reaction. So I decided to give it another rinse with nitric acid to dissolve any possible base metals. However, the first batch of nitric acid seems to be good enough to dissolve 99% of base metals. First I start with washing the used nitric acid, so I add some water to dilute solution. Then I pour upper liquid to my nitric wash container, trying to not let any ash powder enters into the wash container. As I said before, I keep this washed nitric acid solution in a separate container to check later if there is any silver. When washing done, I add some fresh nitric acid to the ash powders, and I repeat these washing steps again. As the nitric acid I used is hot and has some vapors, so I turn the fan on. After 2 times treating the ashes with nitric acid to dissolve base metals, we need to wash it properly with water to get rid of any base metal that has been dissolved. So we need to reach pH around 7, that is natural pH. That's how we understand that there is no proton ion and also metal ions. When adequate washing done, it's ready to treat with aqua regia. So to make aqua regia, I add about 15 milliliters of nitric acid that is 50% concentrated, and 60 milliliters of hydrochloric acid that is 30% concentrated, and also I add some drops of concentrated sulfuric acid to prevent lead metal to be dissolved. Aqua regia solution needs some heat to get some kind of activation. When aqua regia solution prepared, I start adding it slowly to the powder to dissolve gold.
It is very important to not use too much nitric acid to make aqua regia, because at the end, when you want to drop the gold, you will face some troubles while neutralizing nitric acid. When no more bubbles come out of the solution, that means most of gold has been dissolved, and now I want to test solution with stannous chloride. By adding 1 drop of stannous chloride to the sample, you will see, oops, dark brown color due to the high concentration of gold. To do so, I use another batch of aqua regia to dissolve any trace of gold that remains and collect all the aqua regia that I use. So I start transferring the first batch of aqua regia to another jar and adding some fresh aqua regia. Letting solution sit for several minutes and collecting all aqua regia that used. Before I start washing, I add some pool chlorine powder to the solution to produce some chlorine gas at once to dissolve all trace of gold, and then I start washing the solution with tap water. I washed ash powder several times with water to not lose any trace of gold, and you can see the gold concentration gradually decreased by washing. And finally, time for filtration comes. Filtration is done, and this is our gold solution. It is cloudy due to the spilling some powders from top of the filter. But it doesn't matter, we will refine gold after dropping and drop it again. Before dropping the gold, we should neutralize the nitric acid. I use sulfamic acid because using urea doesn't work for me, and I think it's not reasonable. I don't know. I prefer sulfamic acid because it is more reasonable. So I add some sulfamic acid to the solution to neutralize nitric acid. I didn't use too much nitric acid, and I'm not worried about using too much sulfamic acid. So I think 2 spoons is more than what we need, and it's done. Now I stir solution, and then I add SMB to drop gold. We don't need too much, we don't need too much. I think this is about 2 grams, and this is more than what we need. It is better to add SMB while stirring. Now I leave the solution here, and I will check it out after several minutes. After a while I came back, and color changing isn't very obvious due to the impurities that is suspended in the solution, but upper layer of solution is lighter than down layer, and it means gold is dropping. To making sure, we need to test our solution with stannous chloride. I pick a drop on this palette, and I add 1 drop of stannous chloride. As you can see, we have almost no gold in the solution, and the color changing is very light, and this means gold is precipitating. To completing the reaction, I let the solution settle for a few hours and I will back later. Before letting the solution down, I noticed something here. As you can see, there are yellow powders of gold. Amazing. I haven't seen gold be that yellow in first drop. Nice.
Solution set overnight and gold dropped completely. And as you can see, there are some impurities lay on the top of the gold precipitate. So this time I want to dissolve gold powder in aqua regia again and precipitate gold, this time using oxalic acid to get high purity gold sediment. After draining and washing gold powder properly, it is ready to be treated with aqua regia for second time to be refined. When no bubbles come out of the solution, it's ready to be filtered and dropped again using oxalic acid.
This is our gold solution in aqua regia that has been filtered, and this is solution of oxalic acid that I adjusted the pH to be a little acidic, something around 3 or 4. I do that by adding some ammonia solution. By testing by pH indicator paper, it shows something around pH 4. That's right. By judging solution appearance, it is cloudy after addition of ammonium hydroxide. We don't need too much since we just need to adjust the pH, and the solution shouldn't smell ammonia after stirring, so we don't need too much. And now we need to neutralize nitric acid that is present in aqua regia solution by addition of sulfamic acid, and this is solution of sulfamic acid, about 2 grams in 20 milliliters of water. So I start adding sulfamic acid solution slowly to the gold solution to neutralize nitric acid. Shake it properly. You can see the bubbles of nitrous oxide comes out of the solution. To precipitate gold, we need both solution be hot, aqua regia and oxalic acid solution. So I place them on hot plate to bring them near the boiling point.
As you can see on the back, there are 2 flasks that needs to be described. To describe it better, we need to flashback while gold solution is on hot plate to become ready. This is the all nitric acid wash that we use to dissolve base metals. As I said before, I collect them all and now I wanna check for silver. By addition of some hydrochloric acid, white precipitate forms that needs to be checked that if it is really silver chloride. To dissolve any silver chloride that if is present, I add some ammonia solution to the white precipitate. After addition of ammonia solution, precipitate turns black. I thought it is worthless to proceed more than this to find out what we are facing with, but my curiosity didn't let me to stop at this point, so I decided to let it settle down to separate black precipitate and liquid on the top by filtration for further processing. As I know the metals chloride that turns black after coming in contact with ammonia ammonia solution are mercury dichloride and tin dichloride, that in this case mercury chloride is less likely. I washed ammonia solution several times and separated from black residue. And now I add hydrochloric acid to acidify solution again to precipitate any silver chloride. Nice clothes, I really didn't expect to be that much. After we have done with addition of hydrochloric acid, I placed flask on the hot plate to get high purity silver chloride crystals, and I started processing the black residue to find out really what it is. So I add some sulfuric acid and aluminum powder, trying to react the black residue with these materials to reduce it to metallic form. Now gold solution is ready to be dropped, and we will check silver and black residue later.
Gold solution is hot enough near boiling point, and I start adding gold solution to oxalic acid solution. This causes the gold solution become shocked by high concentration of reducing agent, that is oxalic acid, and this will allow gold drop faster.
As you can see, beautiful crystals of gold are forming in oxalic acid solution. Keeping solution hot is necessary to completing the reaction, because we are using an organic reducing agent that is oxalic acid, and the reaction may take several hours to be completed.
After about 30 minutes, you can see gold foil that has been formed on the wall of this beaker.
After 3 hours, gold became heavier and sank to the bottom. But solution still has orange color, and this means we have some gold in the solution, and we should give it more time to reaction be completed. And this is from the macro view. Very beautiful. Never seen such a beautiful thing before.
It's about 20 hours that gold solution left on the hot plate, and the reaction seems to be completed by observing solution color and also testing with stannous chloride. First, I add some water to dilute solution.
I washed gold powder several times with tap water to get rid of all chemicals.
Look at that. I really enjoy watching this. I don't know why, but it is one of the most beautiful things that I have ever seen. Beautiful.
To further washing of gold foil, I place it in diluted nitric acid on hot plate.
While gold solution is boiling in nitric acid, I place it there to process our silver chloride at meantime. To start processing silver chloride, I add some sodium hydroxide because I want to turn it to black silver oxide and then reduce to silver metal by adding some glucose. I start adding sodium hydroxide flakes. I hope to see
color change, but there is nothing yet. I think I should shake it to better the solution of sodium hydroxide. Or maybe some heating could help. To accelerate the reaction, I decided to put beaker on hot plate where there is our gold. And from this point you can see there is some black shades here, and silver chloride start to reacting. As you can see, silver chloride started to turning black by reacting with sodium hydroxide by application of some heat. As you can see, no more white particles are obvious and all turn to the silver oxide. So I start adding glucose solution. Actually, this is the glucose solution that used for doing OGGT medical laboratory test. Actually is glucose tolerance test. As you know guys, I'm medical laboratory technician, so I had this from one of my patients. So I start adding this slowly to the silver oxide solution. This is pure dextrose. By adding this, the black color starts turning gray. I don't know you can see it or not, but all is turning gray. I let it sit for several minutes. Now I want to process gold foils and particles that is boiling in the nitric acid solution. I washed gold and silver precipitate once with tap water and then with ammonia solution to be prepared for melting. And now both are ready and completely washed and ready to be melted. Look at that nice gold color. My propane torch seems to be not hot enough, so I switched to an oxyfuel torch. I use a potato as a crucible for melting silver powder. This is the black residue that I collected from nitrate solution and then has been separated by using ammonia solution from silver chloride, and I think it is tin metal hydroxide. I tried to reduce it to metallic form by reacting in acidic condition with aluminum powder, but it seems to be unsuccessful. Actually, it doesn't worth it to do all of these hard works to reduce and process this black residue, and I just did it for investigation, and I'm really happy with the information I've got and hope you enjoy. As you can see, guys, this is very beautiful gold nugget, and I really enjoy watching this gold nugget. 24K, very beautiful, and it is have a too much density, heavier that you really expect. And this is the silver. We got nice glowing of silver, and I'm really happy also with silver result. And finally, it's time to weigh the metals that we got. First, for the gold, .37. It is really good, and I'm really surprised since I didn't expect to collect 2.4 grams of 24K gold from only 270 grams of BGAs, and it is very good, and I'm really happy with the result. And it was my first experience processing BGAs, and this result is very inspiring for me. I really surprised. And our silver 0.95, about 1 gram of silver. That's good. It's supposed to be waste in nitrate and drain out, but my curiosity didn't let me to dispose this, and that results in getting about 1 gram of silver, and I'm really happy with my curiosity, and both are here, silver and gold. These 270 grams of BGAs was from about 4 kilograms of mobile board circuits, and these are SMD capacitors that I have collected from that 4 kilograms of mobile board circuit that I wanna process it later in my future videos to extract palladium and some silver. This is my lab that I built it with my own hand. Actually, this is a balcony lab that this stand is suspended on the air. I made it floating on the air, and you can see from this window outside. This is 4th floor of apartment. And these are blanks weight of this slide that I built it to better exhausting of fumes. Here is really messy after 3 days working on BGAs to extract that amount of gold and silver, and waste container is full. Here really messy, and bottles here that need to be cleaned. Hope you enjoy, guys. I did my best to make a video for you guys to really enjoy. I have a lot of cleaning job here, and please don't forget to subscribe and stay tuned for my next video. Thanks for watching.